The principle of the aquatic desalination technology is cold boiling. That is, water can boil at room temperature if certain conditions are met. In this example, a container of water at 23 degrees Celsius will be placed inside a chamber connected to a vacuum pump. Once the water container is enclosed and the vacuum pump is engaged, it lowers the pressure inside the chamber to the point where the water starts to boil, while the temperature remains effectively unchanged. Using this principle, we proceeded to design the vacuum chamber that would be used at commercial production scale to cold boil seawater so that the steam collected during the boiling cycle would be condensed into fresh water. We selected a stainless steel fabrication specialist who built the chamber to our custom design specifications. All materials and components used in the construction of our vacuum chamber were made entirely from marine steel. That is 316L grade stainless steel, which can effectively resist seawater corrosion. The chamber was rigorously tested for vacuum sustainability before being shipped for further design. The dimensions of the chamber allowed an optimal fit with a standard shipping container. The container serves multiple purposes, including ease of shipment, chamber surface protection, and the ability to stack chambers vertically to allow scalability as production volume demands grow. The next step was to manufacture the equipment, which we have custom designed for our desalination process. Equipment included seawater preheating system, condensate chiller, thermal compensators, as well as standard components such as liquid ring vacuum pump, seawater transfer pump, and so forth. The final step before proceeding to the pilot site was to install various thermodynamic components inside the vacuum chamber. We chose to conduct the test pilot in the Cebu province of the Philippines, specifically Mactan Newton Beach. The long pier and easy access to the deep ocean stream made Mactan Newton Beach an optimal pilot location. So, after preparing the platform, making electrical connections, laying the intake pipeline, and configuring the equipment, we proceeded with the test. The first step was to preheat the incoming seawater. Our process requires the seawater to enter the chamber at around 42 degrees Celsius. The preheating occurs as the water passes through the thermal oil-based heating system. Heating step, we also use thermal compensators to maintain temperature consistency inside the evaporator section of the chamber. A series of heat exchangers and other auxiliary equipment ensure constant water temperature and flow rate. Once the water enters the chamber, we engage the liquid ring vacuum pump to lower the pressure inside the vacuum chamber. The seawater enters the evaporator section of the vacuum chamber at around 42 degrees Celsius, which is our target. The pressure gauge indicates the depth of the vacuum level inside the chamber. At around 350 torr of vacuum pressure, which is just below half of the atmosphere, the gases begin to separate from the seawater in the chamber. Removal of various dissolved gases and other contaminants from the water, including carbon dioxide, purifies the seawater considerably and raises the pH level of the resultant drinking water. As the vacuum level reaches 65 torr, you can begin to see the start of the boiling process. As the pressure drops further, down to 60 torr in this case, the boiling intensifies further. Now at 55 torr and below, the target boiling point is reached. At this stage, the condensation equipment kicks into gear, which allows the freshwater production to begin. Because the condenser equipment is uniformly distributed throughout the condensation section of the chamber, the freshwater production is evenly distributed. Once we were satisfied that the process works as designed, we placed several containers inside the condenser section of the chamber to collect the product water for laboratory testing. One of the advantages of the aquatic desalination process is that the water is immediately suitable for human consumption without the need for further post-processing. As the lab report confirms, the quality of the aquatic water features superior performance indicators in terms of pH, total dissolved solids, and hardness levels. Specifically, based on the lab analysis report, pH level is 7.44, TDS below 16, and total hardness under 13.